everyone, I'm Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. We selected the topic Problems on Double Integrals for discussion. First, we will discuss the definition of double integral and problems based on double integral. The double integral, the Cartesian form, is this is the formula, that is double integral capital R represents region. The function in terms of x and y, that is f of x comma y, and dr, that is a complete region we are going to evaluate. Otherwise, the double integral capital R f of x comma y, the dr, that is in two dimensions, x and y, it is there. There is a reason here, dx dy. The concept behind this formula is this is a two dimension. Here, the region it is there. This region is capital R, and we are dividing this region into n times. That is, this is del R1, del R2, so on up to del Rn. N times, that is the region, the complete region R is divided into n subregions. Each subregion, the points are there. Now, all the points are connected to this region. That is the function which is defined, f of x comma y. Now, this del represents, this is a delta. The delta represents, that is, the interval is, suppose, xi minus 1, xi. Infinite number of points are there between this closed interval. Suppose a particular region is there. That region is del xi. It's nothing but xi minus 1. This is the way this delta which is defined. Now, the sum of all these regions, that is del R1 into the function plus the function into delta R2 plus so on up to n times. This all the sum, if we do it, we will be getting this formula. So now, this is the concept of the particular region divided into n times. Suppose that n tends to infinity, the region will tends to a point. If we add the complete region, we are getting f of x comma y into dx dy. That is, with respect to x first we will do the innermost integration, then the y will be for outermost one. So now, is it strictly we have to do it always the innermost one with respect to x? It depends upon the limits. 4 limits we have, that is here 1, 2, 3, 4. That depends upon the limits. If they are constants, then we have the liberty to do First one with respect to x or with respect to y, anything we can do it. But if the integral, the variable which depend, suppose y depend on x, that means the integral is a function of x. Y is depending, then interior integration should be with respect to y to be done. So now this is the formula we completed about the Cartesian form regarding double integral. Now, suppose if it is in polar form, then the integral is here radius and angle we will be taking the directions. That is the innermost one with radius from R1 to R2. So we are doing the innermost integration with respect to R. The outermost one with respect to theta we are integrating. Suppose in case the Cartesian form which is given, we want to convert it into polar form. Then here, this is the thing f of r comma theta dA. That is this the complete the Cartesian form we are converting into polar form. Then this dx dy, here Jacobian formula we have to take. So using the Jacobian formula, if we derive, we will be getting this format, that is dx dy will be r into dr d theta. So this is the final formula using the double integral for the position changing from Cartesian to polar. That is f of r comma theta into r dr d theta. This particular which is replaced by this one. Then the innermost is with respect to r we have to do the integration. The outermost is with respect to theta. Now we will evaluate a problem, that is double integral e power ax plus by dx dy over the triangle bounded by x equal to 0, y equal to 0, ax plus by equal to 1. The solution. Now, this is the condition which is given. Using this condition, the triangle will be formed. First, we will see it. We will draw the diagram according to this. What are the conditions are given? Now, looking at this question, which is in the Cartesian form, so the two dimension it is, and x and y two variables. That is the definite integral which is related to two variables, then it is double integral. That is the reason here two integral symbols are there. Now we have drawn here x-axis and y-axis. The origin we named it as O. Now the naming part we are giving the horizontal line as x-axis, the vertical line as y-axis. The coordinate is of the origin is 0, 0. Now this is the condition which is given here. That is ax plus by equal to 1. Here y equal to 0. If you substitute in the place of y equal to 0, the condition which is given in the question, then ax equal to 1, x equal to 1 by a at y equal to 0. So now at x-axis, There is a point, it is there. At the point 1 by a, and the time the y is, if the point lies on x-axis, y is 0. So that point we are naming as P of the coordinate 1 by a comma 0. So the next one, ax plus by equal to 1. Here we are putting the condition what is given, x equal to 0. Then by equal to 1, y equal to 1 by b. So the when y equal to 1 by b, that time x equal to 0. So the y equal to 1 by b, which lies on y-axis. So that point we have taken it as q. So y 1 by b, the time x equal to 0. So what is this condition which is given? We substituted in the given equation, and the point which is intersecting with the x-axis, the point which lie on y-axis. Now we are going to join the P and Q. So after joining, that is O, P, Q, O. So the triangle is formed. That is the reason here it is given in the question itself using this condition. If we draw the figure, it will be a triangle. So exactly, even we too got it, the triangle. Now, this region which is bounded this triangle, this region we have to find using the double integral. This is the function which is given. To find this, evaluate the area of this region, two ways we can evaluate. Here the vertical lines are there. The vertical way also we can evaluate. Otherwise, the integral horizontal way also we can evaluate. Now, we are going to evaluate vertically. For that, we are going to take a vertical strip. Yes, this strip we are giving the name AB. So, to using the vertical strip, how to evaluate this region? The strip where it starting, it starts at x-axis. It ends at, that is the line which is formed joining P and Q. This line, how we got it? Joining the point P and Q, this P and Q, the coordinate from where we obtained it, we obtained from this equation. So that is the reason here the arrow marker represents this is the equation. So the complete question, the reading, we have drawn the diagram. So this is the question we are solving. This is the bounded condition. So already the animated one, each and every line, we discussed it. So the complete figure, which is the grouped figure, it is kept here. Now, the region, this is the region for the integration is ready. It's nothing but triangle OOPQ. It is written here. The integration can be done with respect to any variable. That is, here the integration, the question which is given with respect to x first, and the outermost for y. Is there any changes? No changes, because here this is also constant, here constant. Completely four limits we are getting here. This particular thing we are getting completely constants. If they are constants, we can do the integration with respect to x or y. Now we have drawn the strip. The strip, the AB is the strip which is parallel to our y-axis, which starts from x-axis and where it ends touching this line. This line, it's nothing but this one. That's what completely, looking at the diagram, we have written here the vertical strip AB, which is parallel to y-axis, which starts from x-axis and terminates on the line AX plus BY equal to 1. So this is the figure. Limits of y, we want it now. So the limits of y, the vertical strip, where it starts, very clear, it starts from x-axis. So here it starts from 0. Where it ends, in the line it ends. So we want to extract from here what is y. That is ax plus by equal to 1. By, it's nothing but 1 minus ax. Y equal to 1 minus ax by b. That's what it is written here. So the y limits, the clear picture, we got it. Now the vertical strip, x limits we want it. So here the strip, it is there. The strip left side, the point, what about x? It's 0. The vertical strip, the x direction, what is the right side point? That is 1 by a. That is the reason these two are considered from x limits from 0 to 1 by a. Now the double integration, here the innermost one from y equal to 0 to 1 minus ax divided by b, and here x limits from 0 to 1 by a. The function which is given in the question, e power ax plus by dy dx. So now it's written once again, this innermost integration. Here the variable y depend on x variable. So y is depending. That is the reason we have to do integration with respect to y. That is, the integration is a function of x. The next, this is x equal to 0, x equal to 1 by a. The outermost we will do with respect to x. That is dx. Now the function e power ax plus by, which is given. According to exponential law, that is a power m plus n, we can write a power m into a power n. So here it is written e power ax into e power by using this exponential law. Here we will do the integration first with respect to y. This e power x, which is treated as constant. The two ways are there. Just keeping here, treating as constant, we can do partial integration. Otherwise, anyway it is treated as constant, we can keep the front of the integral. Both the ways are correct. Now, just we kept it here. We are doing the integration e power by dy integral. So e power by integral, it's nothing but e power by divided by the coefficient of y is b. So divided by it will become. So here the careless mistakes regarding integration, if it is there, the coefficient divided by we will write. If it is differentiation, we will write into multiplication, we will write. So the difference between differentiation and integration regarding the coefficients, we have to be very careful. So this integration we completed. Now the limits are, that is, the lower limit is 0. This one just we copied it. And the upper one is 1 minus ax by p. Just it is written here. Now in the place of in the place of y, because we did the integration with respect to y, the y where it is, we are going to apply, we are going to substitute the upper limit. That is here e power by of 1 minus ax by b. This both the, y place we are substituting. So these both are getting cancelled. So the leftover is e power 1 minus ax. We can see it here. Before that, a small simplification also it is done. That is, b is anyway it is constant. Here we are not going to substitute anything. We are going to substitute only in the place of y. So that is the reason here the 1 by b which is kept before the integral. The leftover e power ax is written. The b already it has come out. So now e power by, the lower limit and upper limits are written as it is. So here we can see it, the last step. So here the substitution already we did in the previous slide. That is, in the place of y we substituted. This b getting cancelled. We got it. This is the term. This as it is. Integral as it is. This is as it is. We completed the upper limit also. This formula, this is the sign related to limit formula. That is upper limit minus lower limit. The upper limit part we completed. This minus sign it is written as it is. Only the thing lower one we have to concentrate. Our lower limit is 0. In the place of y we have to substitute. So now here y place we are writing 0. E power 0, it's nothing but the value is 1. Now here 1 by b, the integral, everything, this both what is assigned here, comparing with the previous step, both are, there is no changes, they are not having any changes, just we have written. Now this place, here e power ax, e power 1 into e power minus ax, This term we can write like this. According to exponential law, we can write e power m into e power minus n. So this written. The next step, we are going to take e power ax inside. So e power ax into e power minus ax, this put together, it is becoming e power 0. So e power 0, the value is 1. So 1 into e. That's what it is written here, e. This minus sign is as it is. E power ax into 1, it's nothing but e power ax. We are doing the comparison. So this we completed the integration. This with respect to y we did, and we substituted the limit also completed. Simplification also we have done it. So now the final, the outermost integration with respect to x, we have to concentrate. So we are going to focus on that. So 1 by b. So integral e dx. So the dx integral is x. This problem related sign as it is written, e power ax integral, we know it, e power ax dx integral, e power ax, and x coefficient is a. As it is integration, we are concentrating, divided by a, the coefficient will play a role. So e power ax divided by a. So this is the lower limit. The upper limit is 1 by a. Now, this 1 by b, it is written, and in the place of, just now we completed the integration with respect to x. Now, in the place of x, where the two places are there, so we are going to substitute the upper limit. So e power into 1 by a, that's what it is, e by a, minus this place we are going to substitute e power a into 1 by a divided by a, this simplification, a cancelled, e by a. So the upper limit, the work is completed. This is the formula sign. Now, in the place of x, the two places in the problem, x is playing a role. Now, the lower limit, 0 to be substituted there. So, here we are substituting. This is totally, it has become 0, minus, this minus is problem related, e power 0, the value is 1, 1 by a. So we got it, minus 1 by a. This minus sign related to our problem, this minus sign related to our formula, that is limit to formula applying sign. Now finally, this both are getting cancelled. So 1 by b, minus into minus, it is becoming plus. So we are getting 1 by a. The final answer evaluating our given question is 1 by a by b. We will come to a conclusion of this topic, problems on double integrals. First, initially we discussed regarding what are the formulas related to double integral in Cartesian form, in polar form, from Cartesian to polar, everything we discussed, that is the given region which is divided into n times. Suppose if n times more going on. Infinity stage, if you are dividing, the region will become to a point. The concept we discussed, and we have taken a problem. The function f of x comma y is e power ax plus by. It is in Cartesian form. The difference between also we discussed. If it is in Cartesian, it should be in x and y directions. What is the bounded conditions are given using the triangle is formed. So this is the figure. We got it using this the bounded condition. Here, to evaluate the area for this function using the double integral vertical strip concept we have taken. So the limits for the vertical strip, where it starts, where it touches the strip, the limits are concentrated on that basis. For the y direction, for the x direction, the strip left side and right side, the x points are taken from where to where starting and where ending. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.